All right, guys, so what I'm starting doing right now, I'm going to start recording a lab, and it should not take us too long for the lab. So here I open up a Windows machine. I open up my Windows machine. You can do the same if you want. And I'm going to put it full screen. I'm going to bring a packet tracer. I'm going to open up a packet tracer, bring a new and empty packet tracer. I'll do no over here. All right, and all I'm going to do, I'll drag two computers. All right, two computers. And let's drag a computer and a server. And in order for you to see what is happening, I'm going to go ahead and put a server over here. I'm going to ask you some questions. All right, so first of all, in order for these two computers to talk to each other, both of these computers need to have what we call a name. So I'm going to go ahead and click here and type, let's call this one PC1. All right, and go right here and call this one Server 1. All right, so we have PC1 and Server 1 here. Now, we need to connect them. We can use a switch if we want. We can use a hub if we want. But to simplify the network and for you to see what is happening, what I'm going to do, I'm going to connect them directly. Is it possible? Yeah, we can connect computer directly by using two computers directly by using something known as crossover cable. So I'm going to take a crossover cable and go from here and move straight to here. So what I did, I took two computers and I took a crossover cable from here and I connected these two computers. As you see, the light is green and they're on. Next thing, we have the name, right? We have the name, we have the cable, we need IP addresses. So this computer needs an IP, this computer needs an IP because as it is, they don't have an IP. All right, for two computers to talk with each other, each computer needs to have a name, all right? And each computer needs to have an IP address. So let's go ahead and assign IP address. What I'll do here, for this computer over here, I didn't want to click on you. I just want to assign an IP address right here. Right here, I'll type 192.168.1.10, and the subnet mask I'm going to use is 255.255.255.0. That's the only information that I need for now for this computer. All right, and because I'm going to do it lazy way, I'm going to go ahead and copy, and then paste. Paste it here. However, I need to change. I can't use, no two computer can use the same IP address in a network. It's almost like two phones have the same phone number. It would not going to work. All right, so we have the name. What's the question, sorry?
How did you just change your IP address?
I just clicked on it, and then once I click inside and change the 0 to 1. Got it?
No. Give me a second.
You just click. Watch what I'm doing. I just came here. First, let's say, I was up here, outside. I click here, anywhere, then go inside and change it. You have to click at a number on the IP. All right, so once I did that, this is just labeling. Now I need to go inside each computer and assign this IP over here. How we do that? Well, here's how we do that. I'm going to click on the first computer. All right, so you guys can see it. Move this one here. I like to see what I signed. And go to desktop, go to IP configuration, and type the IP, which is 192.168.1.11, and the subnet mask will be automatically added. All right? I will go ahead and do the same thing for the other computer. For the server, I click on the server. I'll go to the desktop, and I'll go into the IP configuration. And again, I'll move so I can see the number I gave it. I gave it 10. So I'll go, oh, it's good to see it. All right, that's a good practice because we do a lot of numbers, and it's easy to type in the wrong number. So 192.168.1.10, and the subnet mask will be added automatically. Now, for this server, I'm just going to add something so you guys understand communications. All right, I'm going to go into services, and I make sure that the HTTP is on. Another way, I'm turning this server into a web server. I'm turning it into a web server. So I'll make sure that the HTTP is enabled. Anyone has any questions?
Um, 192.
All right, so the server IP is 192.168.1.10. The subnet mask is 255.255.2.0. All right. The computer has, the PC has 192.168.1.11. The subnet mask is 255.255. You guys are gonna know why and how I chose this later on. For now, you just have to let's do it. All right. Now we need to know. We need to go into this computer and see that this computer they really have an IP address and they really can talk to each other. Well, how do we do that? There are a couple of commands that we use. One of the first commands that you're going to learn today, all right, in Windows environment, you're going to learn how to use ipconfig/all. You're going to learn how to use ipconfig, and you're also going to learn how to use ping, right? So ping, we use it to test communications. Let's go and start this, learn how to use this command right here for today, all right, to check communication. We're going to click on the server. You know what, let's do it on the client. Server is always really up. We go into the PC. We're going to go into the command prompt. Click in the command prompt. I'm going to just make this one a little bit so you can see better. All right. And what I'm going to do, I'm going to type ping. And what I'm going to ping this computer IP address and type 192.168.1.1.10. All right. Now I'm going to go ahead and hit enter. I'm sorry, my mistake. Let's do the commands in order. First is IP config / all right, what this command does, displays the TCP IP configurations, displays this computer configuration. So type IP config / all, and you hit enter, and you're going to see, if you scroll a little bit up, maximize it. You're going to see the settings that we assign, and that's what I meant. Every computer has an IP address, every computer has a subnet mask, and every computer has a MAC address, right? So we have a name, computer MAC address, computer IP addresses. This is are required for two computers to talk with each other, right? All right. Next thing, so what's the difference between ipconfig / all and if I just type ipconfig? If you only type ipconfig, you're going to get a shorter version. You see, here is ipconfig. Here is really short. There's not, ipconfig shows a lot of other stuff, including a lot of details that you don't see in what do you call it, in ipconfig, right? Now, so the two commands that I used, the first one was ipconfig / all to display details about the Ethernet connections right here. Right. Going down here, I tried ipconfig, and I'm sure you noticed that not everything is displayed when I type ipconfig. One thing that is missing, it's information about, for instance, about a DNS and a DHCP. They're not really displayed there. Now, let's go ahead and test communication between the PC and the server. And the command we're going to use is called ping space 192 168.1.10. 192, 168.1.10. And then you're going to hit enter, and you can see it is replying, and you say, okay, oh, I can see the other computer. I can talk to him. So what happened over here, my computer, this PC, sends a packet to the server, and the server returns that packet. That's what he says. I send 4 packages to that server, and I received 4 packages from the server, and I lost absolutely nothing. That if you ever see this message, that means communication is happening, and both computers are talking to each other. All right. Now what I want to do, I'll kind of close this and close this, but now I want to show you the OSI model communication, and I'll show you packets being exchanged in real time. So what I'm going to do, I'm going to go into this simulation right here. Please follow me. Go into simulation right here. Click in the simulation. All right.
Where did you click?
I'll close again. I clicked all the way down to the right corner. I went from a real time to simulation. I clicked on simulations. All right.
All right.
All right. And so I click on simulation. I don't want to see every single thing because it's more that we can handle. The only thing I want to see, I'm going to see ICMP. And ICMP over here. I only want to see ICMP doing its magic. You see that? Only ICMP. All right? Otherwise, you're going to see a lot of stuff more that you can handle. We don't want that. Fair enough?
Mm-hmm.
All right. So I am kind of make this one a little small so you guys can see. I'm going to move it to place where you guys can see what I'm doing. So I'm going to take a packet from here. By the way, this is a packet. I'm going to take it from here. I'm going to put it here. And I'll tell him, send me to this guy. You see that? And it's pink. And I hit play. See it? Play, play, and then return back. Now, if you come up here, guys, follow me. Come up here, right here, and double click. All right, if you double click here, you're going to see what we talked about today. You see the layers over here? All right, this is the OSI model right here, the 7 layers communication. And you see that the outman, this computer right here, the layers are what layers? You see layer 3, layer 2. See how layer 2 IP address is being used, and layer 2, the MAC addresses are being used, and layer 1, the fast Ethernet is being used. If you go previous layer, it shows you next layer, next layer. So it tells you what happened at every single layer. So this is communication at the OSI model. If you click the outbound for more details, you guys are going to see everything that we talked about today. It's not really clear, all right? It may be a little bit difficult for the first time, but you guys see this is the packet that was sent from this computer to the other computer. Here is the source. Here's the packet. Today you learned that every single packet has to have time to live. Here is time to live, TTL. Today you learned that every single packet has to have a flag. Here is a flag. Today you learned that every single packet has to have a source. Here is the IP source. Today you learned that every single packet has to have a destination. Here are the destinations. All right? All right? So go back to the OSI model. You guys seen communication happening at the OSI model. Any questions? All right. If there's no questions, what I'm going to do, I'm going to go ahead and stop this recording and stop it.
Oh,